Hi, we are Group 15, and in our project, we worked on providing category-specific ratings for restaurants using the Yelp dataset. Let's first establish the context for our project. As we all know, Yelp is a multinational corporation that operates an online urban guide and business review site. In today's world, peer reviews and feedback heavily influence our decision. Hence, analyzing this review feedback information is highly beneficial. The current situation is such that agencies aggregate feedback received from many people and give users a consolidated view using a single scale of like 5-star or 3-star ratings. These consolidated ratings are not the most informative information available to the users and businesses, especially when they are seeking specific feedback on aspects of business. We seek to address this problem in our project. Our objective is twofold. We aim to provide category-specific reviews for restaurants in the following categories: ambience, food quality and taste, service quality of the restaurant. Also, it is important that a robust classifier is built which can handle changes in reviewing trends in the future with minimal maintenance. Our proposed approach involves these steps in sequence: data handling, featureization, feature selection, and modeling. Let us walk through these steps. The Yelp dataset contains 5 JSON files. Among these, we are interested only in the business and review files. We first converted these JSON files into a standard CSV format using a Python script. Subsequently, we used a VB macro to link the business and review datasets.
Before delving deep into the technical aspects of this project, we thought it would be apt to visualize the entire dataset and see how the reviews cluster themselves. Visualization was done using the existing Pearson correlation implementation. After the data preparation phase, the next step was featureization. Once we got the consolidated text corpus of reviews, we performed some amount of text pre-processing. The objective of this was to convert the text data into a feature space that would help us apply cluster models and assign reviews a 5-star rating for one of the chosen categories. After featureization, we were interested in extracting categorical ratings for each review text. Our objective in this phase was to assign for each review text a star rating for each category. However, we have no ground truth for being able to rate each category on a 5-star scale. To solve this problem, we surveyed 50 peers to obtain keywords that would be used as the selection criteria. We then matched features with the category keywords. This table contains the top features with maximum number of hits. We can see that the tone of most of these features are positive. We then generated n-gram features with n up to 3 for each of the 3 review corpuses and identified reviews having good match and representation of various rating levels by comparing it with the surveyed keywords. We found that in our case there's a high dimensionality in comparison to the number of reviews. Hence, we applied PCA dimensionality reduction technique to these features. The elbow plots show variance retained for each of the categories. As mentioned earlier, our problem falls under unsupervised classification type. Hence, we decided to apply a clustering technique. We opted for k-means-based clustering with k equal to 5. To deal with manual labeling of very large clusters, for each category, we initially dealt with a subset of random samples and clustered them. Shown above is the distribution of ratings in the different categories. This table shows the distortion values for the clusters. We observed that the distortion value for ambience is greater than that of other categories. This is due to the cursive dimensionality for this particular category. When we want to capture new information, we do the following. For each review that's assigned to a cluster, we recalculate the cluster mean and distortion. This is compared to the original cluster distortion value. We keep account of the number of reviews that cause expansion to the original cluster's reach. When this reaches the number of data points, we recalculate the cluster means and store it. This slide summarizes our testing results. As we can see, we obtained an improvement of about 3-folds from the baseline accuracy. In summary, we provided category-specific ratings that provide a better picture than consolidated ratings using an adaptive form of clustering.